Okay, a bit of wrestling and beating, and we have the bearings out of this hub. And so let me show you real fast what we have. Again, this was the shaft, and it sat inside the hub like this. Okay, there's a bearing with the small piece on top and the large bearing size on the bottom. So here's the small one. This is a shielded ball bearing. Okay, so there's balls in there, and then there's a shield there to prevent junk from getting into it. There are ones that are called sealed, and they're tightly sealed, and the grease that's in there is supposed to stay forever. Shielded is just trying to protect the balls from junk falling in them, but the grease can come out. And this is how it came. I mean, there's no grease anywhere left on this ball bearing. It feels smooth enough, but there's no real lubrication in here, maybe just a little bit. So we'll replace it. Now, one way to tell when you're looking at bearings, on one surface there is usually etched the country of manufacturer, Japanese in this case. Sometimes you get a company name, SMT in this case. It can be small. Sometimes you need a magnifying glass to see. And then this case, the bearing is 7R-10. Okay, so each company calls their bearings by different names. It takes a little research. It's usually not that bad on the web. And so what I've learned is R10 is the size of the bearing, and 7 means that it's shielded versus opened or sealed or things like that. Okay, so you can search for an R10 bearing, and what you find out is that it is, and this is just to verify things, it is 0.343 or 344 inches thick. These are SAE American sized bearings. So that's 11/32. The outside is 1.375. Okay, and that's 1 3/8. And the inside is 0.625, and that is 5/8. Okay, and you can verify the inside by measuring this surface here, and there's your 0.625. So 5/8 in inner diameter, 1 3/8 outer, 0.344 thick shielded ball bearing. Okay, so you can find one of these online, $7, $8. Okay. This was a little sneaky thing that was down inside here, and it actually is. So this bearing drives in until it reaches a certain depth, and that depth is given by this Circlip. And so there's a little lip in there, and the Circlip sits inside that, and that defines the depth for this bearing. Okay, so you're going to have to take that out and make sure it's clean in there, and then when you put it back, the Circlip goes in first, and then the bearing drives down and presses up against it, and that's the location. Because it actually sits a little bit lower than this surface here. Flip side, we have the needle bearing that was down here. Now the problem with needle bearing, so ball bearings like this, you can usually get your driving punch onto the edge and drive them out in one piece. I mean, this thing's intact, it spins, it sounds good. Needle bearings tend to get destroyed, and you can see here that there's nothing left inside, and the shell is just chewed up because needle bearings are tall, thin shells with a little cage inside and the vertical needle sticking in. They're very, very lightweight. They're designed to keep an object, an axis centered, but they're not designed to take any sort of torque on them. And when they come out, they tend to get destroyed. So this is a one-shot deal. You better know what you're getting on the other side. So it turned out that before I destroyed this needle bearing, I could read what was on there. And this was an IKO. And what was the part number I had? It was 2216. Okay. And so look that up, 2216 needle bearing, and you can find replacements. And to verify, the needle bearing for this is 1 inch thick. So there's our basically 1 inch. Now remember, this will shoot up, so depending on where you measure it. There you go. So there's 1 inch thick. The outer diameter is, and again, this will shoot up, but there, 1/625. That's 1 5/8. And we can't measure the inner diameter here, so let's measure the inner surface. And that's 1.375, and that's 1 3/8. So 1 3/8 inner diameter, 1 5/8 outer diameter, 1 inch thick needle bearing, 2166, and again $7-8. Okay, and that one, there's a lip here on the inside, and so that bearing drives all the way down into the lip. The way I would put this together is I would put in the needle bearing first, because it's going to be the hardest one to get in. You want to make sure it drives in straight and clean, and if you screw it up, you're going to want this open to get it back out and destroy it. And then you have to order another one, so don't break it. But do the needle bearing first, then put in your circlip, and finally drive in this bearing down in the circlip. And when you're done with all that, you can then take your axis and drive it into both bearings at once. When you're doing this, the needle bearing, you might want to soak it in oil or something to get some lubrication in there. It's going to be hard because it's sealed to lubricate it again, but theoretically a brand new needle bearing should be in much better shape than one from the 80s like this one. I mean a ball bearing. The needle bearing, get a finger full of grease and just grease all the needles before it goes in. And your axis, clean it one more time with alcohol to get the last fingerprints off. Okay, and liberally coat both these surfaces with wax, with grease, and this whole area is covered in grease. Just, you know, thick. It can be sloppy, but cover that in grease. The grease will keep it waterproof and prevent any more rust from forming. And then it'll feed a little bit those bearings and things like that, but it's mostly to keep this waterproof. So then you drive that into the axis, and when that's done, we can reconstruct everything. And we'll do that, next week when I get some new bearings.